Okay, so this is going to be a short video about how to basically read a regression output, because you already know how to put it in your calculator and get the equation. The calculator gives you A, B, R squared, all that kind of stuff. Okay, so there's, like I was saying, there's another type of software called minitab that actually runs statistical software. And if you get into college and you're taking upper level statistics classes, you will have software like this. And we kind of need to know how to read it, because we're still expected to be able to write the equation from this output. Okay. And tomorrow we'll talk about another way that we'll be expected to write the equation, and it's from some other stuff that's actually in your notes. Okay. So real easy. It's very, very specific. You are looking at specifically just this column. Okay. And then if you take a look right below that column, it has R squared. Okay. So you're given everything you need in just that one column. We will actually get to like the T and the P values later when we start running tests on slope. Okay. So the way this works, your constant, okay, think about a linear equation, right? We're writing it as y hat equals a plus bx. Okay. Any kind of an equation, the constant is always going to be the one that doesn't have the variable, right? So that is your y-intercept. Okay, so when we read this, or we're going to write the equation from it, so y hat equals my constant, which is 44.540, plus my slope is going to be the one right up underneath of that. Okay, so it's going to be 0.55528. 55528x. Okay, and if we were going to write this in words, it says exam score versus revision time. Okay, so, we'd be told basically which one is X, which one is Y. We can also take a look. It says that the constant, notice the constant doesn't have a name. The slope part of it does. That basically letting you know that your X is your revision time. Okay, so if we were to write it in words, we are predicting their exam score. And I'm going to shorten the numbers now, because otherwise I'm going to run out of room. 44.5 plus 0.5, we'll say 0.56, because I'm going to run out of room, times the revision time. And, okay, see, it's actually even written above here, but this is actually how you pick it out from the from the minitab software. Most of the time, this is not going to be here. You're just going to be given this block of numbers, and you're going to have to write the equation from that. Okay, so this is just to walk you through it to make sure you can actually write your equations from this. And we can also calculate R, which is very, very nice. There we go. We can also calculate R. Because we've been given R squared, right? And so it's as simple as you think. In order to get R, we're going to take the square root of R squared. Now, here's the deal. You need to put it in. See, notice that it is a percent. I don't know if y'all can see that. I can make it bigger. That is a percent. So you need to put it in the calculator as a decimal when we're going to calculate R. So you're actually going to take the square root of 0.728. And we'll talk again tomorrow about what R squared means, because it's another fill in the blank statement that I need to give you as far as what it means and what it tells us. It's actually some really important information. So we're going to take the square root of 0.728, and we are going to get an R value of 0.85. Now, I do want you to notice something. Okay. Remember that R squared obviously is not going to be a positive or negative, because you're squaring it. But remember, R can be positive or negative, right? If it's a positive or a negative relationship. So how do I know from this information that I'm given whether that R is a positive or a negative relationship? Remember, we talked yesterday, or not yesterday, Tuesday, about how R and slope are related. So if R is a positive, if R is showing a positive relationship, then your slope is going to be positive, right? So our slope is positive, so I know my R value is a positive 0.85, not a negative. Okay, very important. If this slope was negative and they asked you to calculate the R value and you didn't put the negative on it based on the slope being negative, you'd get it completely wrong. Okay, so you've got to make sure you're paying attention to if your slope is positive or negative. It makes a big, big difference. So, and that's a fairly strong positive relationship between these two. So, okay, so we already know how to do slope. We talked about how to write it in context. For those of you who missed Tuesday, make sure you get those notes from in Canvas because we had a specific fill in the blank for that. The y-intercept is 44.540. We talked about this again on Tuesday and Wednesday. Like, what does the y-intercept mean? Right? And how it's like usually a little silly because it's not going to be in a real world situation. Okay, so how do we calculate R? Okay, so the standard deviation of the residuals, something we're going to get into tomorrow. But the standard deviation of the residuals is right here. It's this big S. Okay. Now we talked about how the residuals are the differences between the actual data pieces and like the line, the prediction line, right? You can actually do the mean of the residuals. You can also find the standard deviation of the residuals. And just in case you didn't remember off the top of your head what standard deviation meant as far as definition, we said that when we were doing one variable data, that your standard deviation is the average difference between the mean and each data piece, right? That's what it is in one variable data. It's the same exact thing in this. Your standard deviation of your residuals is literally the average difference between this would end up becoming your prediction or your prediction line and the actual observed pieces. Remember, like predicted minus observed was how you actually find your residuals. So it's the average difference between your predictions and your actual observed data. So the standard deviation is still the same thing as far as average difference. And so it makes sense, since we're looking at all these differences between the pieces and our prediction, to see how good our prediction actually is, right? We want them to be small. That's why it's called least squares regression. So we can actually measure what the typical difference is. So if you're ever asked, and again, we'll talk more about this tomorrow, if you're ever asked what a typical error would be in your prediction, that would be a typical error. So I'm just going to say, I'm assuming that this is, since they're comparing an exam score versus a revision time. So the average difference in the observed exam score and the predicted exam score would be like 6.3 points, right? It would actually have some kind of a unit on it. Okay, so that's it. Again, I made this really, really quick. Pause it, replay it, do whatever you need to do. I think I've left you 2 practice problems. They are on hard copy. Get them from the sub, and I do want them turned in before you leave today. Other than that, just keep going with the homework from this section, keep going with the reading, and I will see you tomorrow. Behave yourself.